This one, when you derive an integral, it's the second fundamental theorem of calculus, because these are t's, and you're going to have an x squared here. So basically, all you do is you take 1 over t and replace t with x squared. But then you got to derive the x squared. Derivative of x squared is 2x. There's your answer. No. Now we simplify it. That's all you do. Whenever you take a derivative of an integral, you plug it in and then derive it and multiply by it. My final answer is going to be 2 over x. Done. Okay. That's a lot quicker than trying to integrate this and then going and deriving it afterwards. Second fundamental theorem of calculus is beautifully short, if you can spot it. This one, find the area bounded by all these graphs, is simply an area problem. Our graph we're dealing with is the first equation. These two values are interval, the vertical lines at 1 and 4. Remember, we always go from the smallest to the largest. And y equals 0 is the x-axis. All integrals are according to the x-axis. So that's all that. All this junk is basically saying this. Oh, don't forget dx. Pretty important. That's all it's saying. You take the 3 graphs, these 2 lines, this top graph, this bottom graph, and then we do this. Now, to do this, it's actually easier to write this. That's your first step. Make it easier on you. At least that's what I would do. Otherwise, you really don't have any method to do that besides a really hard use substitution. And then when you integrate this, 1, the integral of 1 is x. And 1 over x, isn't that ln? So that's going to, can I pull out a 4? Kind of push the 4 over? And then 1 over x is my answer, so wouldn't that just be 4 over x? Okay, the 4 stays on top. No, I didn't. That's not it. That's 4 ln x. I'm thinking backwards. 1 over x, integral of 1 over x is ln x. Got it? It's easy to kind of, for me to mix back and forth. Am I right here? Push the 4 over, 1 over x is ln x. Anyways. And this is from 4 to 1, or 1 to 4. Okay, now just plug in 4, plug in 1, and we're done. So it's simply going to be 4 plus 4 ln 4 minus 1 plus 4 ln 1, which ends up being let's see, 3 plus 4 ln 4. I don't know ln 4. That could actually be ln 16. No, that's right. Say that over again. That could be 4 to the 4th, which is a rather large number. And then isn't ln 1? What's ln 1? That's 0. Okay, because anything 1 is 0. So 4 times 0 is 0, so that's my answer. That's my answer. Which, if you had a calculator, you could finish it. And then the last one, to find the average value, you first are going to take that, which is b minus a, 1 over b minus a, ab. The interval is from 2 to 4 of this equation. If I do this, 1 over 4 minus 2, that's the average of the whole area. This is the area, this is averaging the area, basically dividing by 2, because the width of the shape is 2. And so basically you end up with a 1/2 integral 4 and 2 And then I would change this to 4 over x plus 4 over x squared dx. Now you might be confused how I did that, but I distributed the 4 and then I divided both pieces by x squared. I distributed the 4 and divided both pieces by x squared. The reason for doing that, I put the 1/2 here. This one becomes ln, this one right here, 4 over x, becomes 4 ln x. This one right here, isn't that 4x to the negative second? Won't that become 4 over x? Negative 4 over x. When you add 1 to negative 2, you get negative 1 divided by negative 1. So won't that be minus 4 over x? We're going from 4 to 2. Again, you add 1 to negative 2, you get negative 1. Divide by negative 1. Becomes 4 over x negative. And then plugging all those values in, looks like we're going to have 1/2. And we have 4 ln 4 minus 4 minus 4 ln 2 minus 2. Because 4 ln 2 and then 2 divided by 4 divided by 2 is 2. 4 divided by 4 is 1. So this should be a 1 right here. Yeah. Good. Because again, yeah, you're right. 4 divided by 4 is 1. I did that wrong. And if we simplify that all out, you can't really do a lot of simplification here, but it looks like to me, if we leave the 1/2 out front, we have the 4 ln 4, and then negative 1 minus a negative 2 becomes plus 1. Okay, so that should be right, because this minus this should give us this. Okay. Now, one thing you could do, technically, could you bring these two together and make that an ln 2? Could you have 4 divided by 2? You could do a whole bunch of junk here, like, because these two can group together again using the combination. That's probably good enough.